Transient Plane Source, or TPS, is a thermal conductivity and diffusivity measurement method that complies with ISO 22007-2, ISO 22007-7, and ASTM E3088. It applies to a broad range of bulk materials, polymers, ceramics, metals, composites, and more. If you have a solid bulk sample and you need an accurate thermal transfer data, TPS is a great option. Thermal conductivity and diffusivity determine how a material behaves under heat load. Get them wrong, and the component either overheats or fails to meet performance targets, upstream of safety ratings, product lifetimes, and regulatory compliance. These are properties worth getting right. For TPS bulk measurements, sample dimensions need to meet minimum requirements that scale with the sensor size used. As a general guide, the diameter of length by width of the sample should be at least 2.5 times the sensor diameter, and the thickness at least 1 times the sensor diameter. Flat, parallel faces with good surface contact are ideal. The TPS method uses a thin, flat, double spiral sensor. It acts simultaneously as heat source and temperature detector. Electrical power is applied, heat diffuses symmetrically outward into the material on both sides. The time-dependent temperature response is recorded and analyzed to output thermal conductivity and diffusivity directly. The standard configuration is double-sided. The sensor is sandwiched between 2 matched sample halves. This symmetrical setup gives the cleanest signal. For samples where a double-sided setup isn't practical, single-sided configurations are available using a backing material of known properties. TPS bulk is well suited to isotropic materials. For non-standard samples or more complex measurement needs, specialized utilities are available to address those requirements. Temperature range is flexible. Standard measurements run at room temperature, but the method extends to elevated temperatures for high-performance engineering materials and to cryogenic ranges for low-temperature applications. Beyond standard bulk measurements, TPS on the Trident covers configurations that address edge cases, non-standard geometries, specialized utilities, and temperature-dependent characterizations across a wide range. For researchers working at the intersections of structure and thermal performance, the flexibility in how the measurement is configured is where the method earns its place. Akin Okafor, research scholar at University of Arkansas, used TAL's TPS testing service to characterize thermal conductivity for work that went on to be published in the Journal of Materials Science, Materials and Electronics. This analysis was run on TPS using C-Therm's Trident. When your testing is complete, you receive a TAL report, a structured document covering your measured thermal conductivity and diffusivity values, the sensor configuration used, sample detail, and how results are presented in context. It's not raw data handed back to you, it's a clear record of what was measured, how, and what it means for your material. And if you'd like to talk through the results, we're always happy to set up a call and walk you through them. If you have questions about TPS or want to understand whether it's the right fit for your sample, reach out directly. Contact details are on screen and in the description below. Links to further resources on the TPS method are in the description.